Hey guys, welcome back. Hope you all are doing well. This is Mohammad Badruddin. Today we are going to see the second last lab of HTTP request smuggling, and this is all about client-side desync. So this lab is vulnerable to client-side desync attack because the server ignores content length header on some specific endpoints, and you can exploit this to induce a victim's browser to disclose its session cookie. Now to solve the lab, we need to follow these 4 points. The first one is saying identify a client-side desync vector in burp and then confirm that you can replicate this in your browser. Second point, identify a gadget that enables you to store text data within the application. We will see that in a minute. Combine these to craft an exploit that causes the victim's browser to issue a series of cross-domain requests that leak their session cookie. And the fourth one, we need to install the session cookie of the victim and we need to log into the victim's account. Fine, so this is our lab. Burp is working fine, and you can see a lot of request belongs to something else. I'm just going to clear these a bit so that we will have the better view. Fine. Okay, so this is our web root request, and I'm going to see the response. You can see it is going to redirect us to an endpoint which is /en, and this is the /en endpoint that contains the normal response 200 OK and the content of the web page for the home. Okay, so I'm going to send this request to the repeater, and also I want to send this request to the repeater. One thing I would like to mention here, if you do not get the session cookie into your web root request, just refresh the browser or click on the home button one more time so that the request you find here with the session cookie. This is important. Fine. Okay, back to the repeater, and here we have these two requests. This is the web root request. I'm going to send this request, and you can see 302 found, the normal as expected. Now one thing to be noticed here, that if I just go to the request attribute and change the request attribute to HTTP version 2 and send the request, you can see server ALPN does not advertise HTTP 2 support, although you can force HTTP 2 from the repeater menu. So if I come here and even if I click on allow HTTP 2 ALPN override and send the request, it will say stream failed to close correctly. Okay, that means it does not support HTTP version 2, and this is what we need. So second thing, I would like to change the request method from get to post, and we need to clear this up. So I don't need all of this up to here. We just need the session cookie, not lab analytics. But even if you have the lab analytics cookie, it will not affect much. Okay, fine. So this is what we have now. Let's see. So here, even if I change the content length, I need to make sure, because the lab is saying that there are some specific endpoints where the content length is ignored by the server. So I need to check that. So if I make it 10, although we don't have any data in the body section, because this is the post request, so post request have data in the body section, although we don't have anything, but the content length we mention here is 10. If we send the request 302 found, so that means the content length doesn't count here. One more thing, because update content length was turned on, so I just turn it off, change again, and make sure we get 302 found, the normal response. So if the content length is being interpreted by the server, then it will wait for a long time to just try to read the data in the body section. But because the content length is ignored by the server, so it is not waiting for any data in the body section and giving us 302 found. Fine. So this is what we need. And now I'm gonna add here get / let's say anything http/1.1 and a fake header. Okay, and now if we send the request, it will again give us 302 found. Why? Because it doesn't matter how much data you put in the body section, because the server does not see the content length. Fine. So you can see here, if we highlight it, the content size is in the body section 35 bytes. So now I'm just going to click on update content length and send this request. You can see 302 found. Now what I need to do here is I'm going to create a tab group, and this is going to be the first tab is going to be our smuggled request or the attack request, and this one will be the normal request. Create it, and I want to send this request in a sequence within a single connection, right? So here you can see there is no data, no response, because we did not send this request. But now once we send this group in a single connection in the sequence, so we should see here 302 found, and we are redirected to /en. And once we go to this request, you can see not found. So this confirms that the attack request is working fine. So now one more thing I would like to do here, which is connection keep alive. I want to add here one more header. Connection, its value is going to be keep alive. Okay, this is important once you send the request in a group. So send it again, 302 found, and here 404 not found, because /anything, this endpoint doesn't exist. Okay, so this confirms that we can cause the desync. So now it's time to replicate the desync in our browser, and for that purpose I will use another browser, Google Chrome or Chromium browser, whatever you have. So Google Chrome with no sandbox. Okay, it's up, and I'm going to just take this, go to the Google Chrome, paste that. Okay, hit enter. So this is our lab. What I need here is go to the inspect. Okay, and here I'm gonna see the network tab and make sure this preserve log is checked, and if there is any connection here, so or any log here, just clear it by clicking this button. Okay, then we need to go to the console, and here we basically need to write the same attack request what we had here. Okay, so for that purpose I'm going to open it so that I can write the script here for sending this specific request, but with the fetch API. And for that purpose, to save the time, I'm just going to take it from the lab solution. I already copied it, so I'm going to paste it here. And what we need here is we need to take it, copy back here, and paste this. Also, we need to paste it here. Fine. And here this is an invalid endpoint, so we write here anything. Okay, HTTP 1.1, then this is the character turn line feed, and foo x, this is basically the fake header what we added, and the request method is post. Mode is CORS. CORS stands for cross origin resource sharing, because as we saw in the lab, it's asking for combine these requests to craft an exploit that causes the victim's browser to issue a series of cross-domain requests that leak their session cookie. Fine. So we must have it in the first request. Now I'm just going to summarize this. So this script is exploiting an HTTP version 1 client-side desynchronization vulnerability using the browser's fetch API. Okay, so the post request is sent to the target website, and the request body contains what looks like the beginning of an HTTP request. Okay, now the goal here, the goal here is to confuse the backend server. So it interprets this body as a separate request. Because of the improper request parsing between the browser frontend and backend server, the malicious payload may remain in the server's connection buffer, and this creates a poisoned or desynchronized connection. So this first request is expected to fail or produce the network error. That failure is actually useful because the exploit only needs the malformed request to read the server. Now you can see about this one. So this is the second request, which is sent immediately after the first one. And if the server connection is desynchronized, this request may get prefixed or corrupted by the smuggled payload. So as a result, the server may interpret the request incorrectly and return an unexpected response such as 404. So once we send this request, we should see two responses or two requests. Let's see, I'm just going to copy that, go back to our Google Chrome, and I'm gonna paste it and hit enter. So once we enter, you can see we get here 404. Now if we go back to the network section, you see here we have the first one, which is 302, and the second one is 404. Fine. So if we open up the first one, you can see in the payload section, this is our request. Fine. This is the first request what we send here, and the payload in the body section is this one. So if we see the payload, we will get the second request. Fine. Here, this is our second request. Fine. And the response is not found because the /anything does not exist. So this confirms that the desync vector can be triggered from a browser, which we just did it. Okay. Okay, fine. Now the next portion of this attack is going to identify a gadget, which we saw here. Identify a gadget. Okay. So to identify the gadget, we actually go to the view post, and here if you scroll down, we will see there is a comment section. So let's just do a comment. AAA, name is SSS, email is aa@mm.nn, and the website is going to be example.com, and post the comment. What it's saying, please match the requested format. Okay, so maybe it needs http:// okay, and this time it's submitting the post. So if we go back to our proxy, here we have, this is the post request where we basically comment. Okay, so I'm going to send this request to the repeater, go to the repeater, and here we basically going to clear everything up to the session cookie. So we have connection cookie. Wait, we actually missed something. Yeah. Okay, so take care about it because the content length and content type headers are important, and the rest of the things we will remove from here. Second thing, I would like to take the comment from here, Control X, and paste it here. Why so? Because whatever data will be append from the victim's request will be append after the comment. Okay, so make sure the comment is in the last. Fine. So just send the request. Okay, 302 found, And if we go back here, back to the blog, we will find that another comment is being added. Okay, this was the first comment and this was the second comment from the repeater. Fine. So what we need is to take this complete request and we are going to add it in our attack request as the smuggled request. Fine. Second thing is, this is the body section for the second request. So I'm gonna see this is 120 bytes. I'm gonna add here 200. Okay, let's just see 200 bytes and send the request. So once we send the request, you can see 302 found. If we come back here, it's everything fine. You can see instead of showing us 200 okay, because if we see the previous request 404, before it was 200 okay, now it's redirecting us to the post ID 6 after the comment. So if we go back to the blog post, see the request, refresh it, now you can see this time it's post a comment, but with the comment it get the second request. Okay, it could be from the victim or it could be from our side. Basically this time it is our request because we did not publish that attack, okay, to the victim, which we will do it from the exploit server. So the important part here is after the comment, it's basically appending the request, and that's what we need, because once we deliver the exploit and the victim will get affected from that exploit, we will capture the request of the victim and the request contains the session cookie. Fine. So go back to here, and what basically we need is to take this second request, copy that and go back to our fetch. This was the smuggled request, right? So I'm going to paste here this one. Okay, so now what we need is we need to just adjust it, like we need to add here turn line feeds like /r/n. okay, and bring that host here in one line. Basically this is the turn line feed. I'm gonna copy it and here I'm gonna paste it, bring the cookie here, also turn line feed, and bring the content type, turn line feed, and after that bring the content length and turn line feed and bring the connection keep alive. Now after keep alive, if you see here, after keep alive we have two turn line feeds and then CSRF and the body section. So we do the same thing here. After keep alive we will put here two turn line feeds, okay, and then bring the CSRF, this body section here. So that is completed. This is what we need. Go back to the browser and go to the exploit server, and here basically we will go again to the inspector section, go to the network section. If you see any request here, any data, just clear it from here. And now we need to go to the console, and in the console I'm going to copy everything what we have here and paste it in the console, hit enter. Okay, if we go back to the network section, we will see three requests here. So the first one give us course error. If we see, this is our request, and within the request, this is the smuggled request, right? So within this request we have the payload, which is this one, and this is the second request. Fine, 302 found. And if we go to the response, the no response. Okay, so because this is actually redirecting us, and this will give us the response to confirming our comment what we try to upload or post. So if we come back here and refresh, you can see the same thing. we found as the previous one. That means it's working completely fine. What I need here is go back to the browser, Google Chrome, and actually this time I'm going to clear everything from here. Go to the console. Okay, clear console also. Now instead of sending this through the console, I'm basically gonna deliver this exploit through the exploit server. So I'm gonna paste that same exploit here, the script what we wrote before, and I'm gonna enclose it within the script tag. So script, and here also script. Okay, here we start the script tag and here we ended with the script tag. Now what we need here is to store this exploit. Fine, and then deliver this exploit to the victim. Okay, so once we deliver the exploit, go back to your go back to your Firefox and just refresh the browser. The same thing we get. Now we just need to increase the content length of the second request here. Okay. So back to the Google Chrome, and here I'm going to actually, instead of SSS, so we know this is the new request coming from the exploit, new response coming from the exploit server. I'm gonna put here capital A, capital A, capital A, and this one I'm gonna increase it to 500, store it, and deliver exploit to the victim. Back to the browser, Firefox, refresh one more time, and you can see this time we get the request, and if you see the user agent, it's saying victim. So intentionally it is done by the port swigger so that it will be easy for us to verify whether the request is coming from the victim or not. So in the user agent you will find victim, so that means this is the victim request, but still we did not find the session cookie, and for that we again need to put here or increase here the content length. So this time I'm gonna put here 700, store, and deliver exploit to the victim. Back to the Mozilla Firefox, refresh. Okay, this time we have more response than the earlier one, but now we need to again increase it, increase the content length. Okay, so make it 800, store, and deliver exploit to the victim. Fine, refresh the page, and hopefully this time we get the session cookie. So we are very close. This is the secret, but still the session cookie is not completed. So just few more bytes and we are good to go. So 850, I think it will be enough. Store it and deliver the exploit to the victim. Back to the Firefox, refresh again, and this time we get the complete session cookie. So I'm going to copy that. Okay, we are already in the lab. Just go to the inspector section, go to the storage, and here instead of our session cookie, I'm gonna paste the session cookie for the victim, hit enter, and go to my account. So we should see the account of the victim, and you can see we are logged in as administrator, and congratulations, you solved the lab. So that's it for this video. Hope you enjoyed. If you like the content, please like, subscribe, and share. I'm gonna see you in the next video. Bye.